Welcome to another exciting educational video brought to you by Upvision Concepts Academy. So in this video, we'll be looking at rate of chemical reaction, and we know that rate of chemical reaction is one of the most important topics in physical chemistry. We'll look at factors of chemical reaction, and even this course or lesson is aimed for grade 11 students, people who are preparing for SSC, NECO, and JAMB examinations. So sit tight and we'll go into the lesson proper. If you're not subscribed to our channel, come into our channel, click on the subscribe button, and don't forget to comment if you have any questions or any feedback for us. We'll treat it surely. Okay, so rate of chemical reaction. The rate of chemical reaction refers to how fast and slow a reaction proceeds. It is the amount of reactant used up or product formed. So by definition, I can say rate of reaction is equals to change in concentration. Concentration is the amount of mole per solution all over time. Okay, so this is usually expressed as mole per dm cube per second. Mole per dm cube per second. Okay, so this is how it's expressed. Okay, so examples, fast reactions. Let's say reactions that occurs in very short time are explosions, acid reacting with base. This kind of reaction, acid and base, is known as neutralization. We've done that. Just check on the video for this particular topic. So acid-base reactions, which are termed as neutralization reactions, are very fast. Okay, then slow reaction, example of slow reaction in terms of time. You have rusting of iron. You agree with me that iron takes quite a while for it to rust. Fermentation, even matter of days. It takes days for fermentation to occur. Okay, so we're going to be looking at the factors of that affects chemical reaction. What will make this one go very fast and this one go very slow? Understand? We'll look at it. So just sit tight. Okay, so the rate of chemical reaction occurs, and as it happens, there are factors that make it go either very fast or very slow. The first factor is temperature. So temperature is the degree of hotness or coldness of a body. So if temperature is increasing, what happens? The rate of chemical reaction will increase. Definitely, the increasing temperature makes the particles or molecules of the reacting substance to become very kinetic. Understand? Becomes the rate of movement becomes greater, so that there will be proper mixing of these molecules or particles of these substances that are involved in reaction. So increasing temperature increases kinetic energy. Of the particles. So that's the explanation, actually. And if the particles' energy is increased, there's more interaction and there's more completion of that reaction. Okay, so what does temperature do? Temperature also makes sure that particle moves faster. Particles moves faster. See, from kinetic energy increase, you see a faster rate, and resulting in faster collision more frequently, and with more energy. So the impact of these colliding particles becomes greater with more energy. Then lastly, on that temperature, that more collisions are successful. So we talked about artificial energy in the previous video. Artificial energy is the energy required to be achieved before a reaction will take place. Either you achieve it or you exceed it. Okay, so more collisions are successful successful, my word, successful, okay, that's the spelling, i.e. with energy greater than or equal to activation energy. Remember this word, activation energy. Okay, so examples of this kind of reaction is magnesium and hydrochloric acid. This occur very, very fast. So that's the X factor, temperature. We'll go to the next one, which is concentration. So the next factor that can affect the rate of chemical reaction is concentration. So concentration is just the amount of solutes per solution. Concentration, measured in moles per dm cube. So if concentration is increasing, what happens? That means you have more particles in that reaction environment, and it will lead to increased reaction. So increasing concentration of reactants are the substances or compounds that are reacting, increases the number of particles per unit volume. Particles per unit volume. So, you know, you see that most of the times it is solutions and maybe gases that we are looking at when we are looking at reactions. We're not saying that solids cannot react, but you see, if you have solutions that the concentration, the particles, the active ingredient in that solution is more, the reaction will occur faster. Okay, so concentration also leads to more frequent collision. Okay, so the essence is to achieve collision, more collision. If you achieve more collision, then the particles will actually mix and react, and this increases reaction rates, and this increases reaction. It increases reaction rates. Rates. Okay, so this is what concentration can do. So example of a concentration factor affecting rate of chemical reaction is when you have more concentrated hydrochloric acid reacting, it reacts faster with zinc than dilute one. So you see that you have two containers where you have hydrochloric acid and zinc, HCl plus zinc. If this one is concentrated, it will be faster than if I have dilutes, hydrochloric acid and zinc. It will be faster. So concentrated hydrochloric acid will also give us faster rate of chemical reaction. Okay, so third factor under consideration is surface area. Surface area is just the area open to the reaction. Surface area. So this one applies to solid reactants. So increased surface area. So if I have more area exposed to the reaction, increasing surface area, e.g. using powdered solids rather than just the solid that are just together, exposes more particles to reaction. Okay, so this one is clear. So when this happens, this leads to more collisions, and faster reaction. So you see, the end goal is to achieve faster reaction. The reverse case is for slow reaction. So if I have that my surface area is not wide enough, the reaction will take some time. But if you have a surface area that is wide enough and there's more contact, more exposure of the substance because of the wide surface area, the reaction becomes faster. Example of this kind of scenario is powdered calcium carbonate reacts faster with hydrochloric acid than marble chips. You know, marble chips and calcium carbonate is the same thing. This is calcium carbonate. Understand? Marble chip. This is the same composition. Marble chips. Now, marble chips is is the form of this in solid form. Chips is a chip. But if you have this marble chip in a powdered form, so powdered calcium carbonate, it reacts faster with hydrochloric acid, of course, to form salt and water. No, salt and water, no. And to form calcium chloride, yes, and yeah. Okay, so that is it. So the next one is catalysts. So the fourth factor that can affect chemical reaction is catalysts. Catalysts, like I said, is a substance that can make a reaction go faster without participating in that reaction. So a catalyst speeds up chemical reaction, chemical reaction. Okay, so without necessarily participating in that reaction, it also provides an alternative reaction pathway with lower activation energy. So it lowers the activation energy. That energy is the barrier that must be attained or overcome before reaction will happen. Catalysts do not affect the equilibrium position. Please, catalysts do not affect the equilibrium position. Okay, so example, manganese 4 oxide is a catalyst. It speeds up the decomposition of water. Water, is it water? No, hydrogen peroxide. This hydrogen peroxide. So when you put magnesium 4 oxide, you now have it broken down into water and oxygen. Okay, it's correct like this. Okay, so you see how we put catalyst. We put it on top of this thing, on top of the arrow leading to the product. It's not part of the reaction actually, so that's why we put it on top of the arrow to show that it's not part of the reaction, but it's there to tell us that it's a catalyst. All right. Okay, so we'll go into the next one, collision theory. Okay, so collision theory explains how and why reactions occur. If there's no collision, reaction will not happen. So there must be a collision. So the main idea for reaction to occur, reacting particles must do the following. One, they must collide. For reaction to occur, the following must happen. The following must happen. Okay, so number one, there must be collision. The reacting particles must collide with one another. Okay. Secondly, they must have sufficient energy to overcome activation energy. Okay, they must have sufficient energy, not just quick collision, not just collide because you want to rub yourselves. You must have sufficient energy. Activation energy must be achieved and exceeded. Activation energy. Okay. What else? Be properly oriented. Proper orientation is also part of factors that will have collision reaction to occur. Okay, so more frequently and more energetic collisions increase the rate of chemical reaction. We have seen how that has happened. I mean, that was used to explain the rate of chemical reaction. Okay, so effects of factors on collision frequency. So those factors that we just looked at, what are the effects? So number one, temperature one of the factors that we discussed. Temperature increases the speed of and energy of particles. Okay. So for us to understand what I'm trying to say, there are the factors affecting chemical reaction. How can I use it to explain the effect on collision frequency? Because those factors are geared towards helping collision to happen. Because if collision doesn't happen, reaction will not happen. So the key thing about reaction is collision. Okay, so let me do it this way so that we can understand it. Okay, so I have on the board this written out so that we can understand what I was trying to say. So we're looking at the effects of factors on collision frequency. So like I said, collision frequency have to happen, or collision have to happen for reaction to occur. And those factors of that increases rate of chemical reaction is basically aiding collision. So we're going to explain how each factor aids collision. So number one factor, temperature. So increasing speed. So temperature does what? Increases speed and energy of particles. So this is how increase in temperature will ensure that collision happen and ensure that reaction rate is faster. Concentration, more particles, more collision. See? Then surface area, more exposed area, more collision. And finally, catalyst ensures more successful collision. So how do we measure rate of chemical reaction? Some common methods include measuring volume of gas involved over time, e.g. using gas syringe. So you can collect the reaction through a gas syringe, and that syringe is calibrated. So you see the volume of gas that is involved over time. Focus is on the product that is produced. The product that is produced, how fast that product is produced. When you measure the fastness, the time, the quick time you achieve production of products, then you can actually measure rate of chemical reaction. Another way to measure rate of chemical reaction includes measuring mass or change in mass. Okay, so e.g. Carbon dioxide loses loss during a reaction with lime. Lime is this. This is lime. Sorry, calcium carbonate. I mean this calcium carbonate first. Okay, so you can measure the change in mass of the one of the reactants. Okay, then you can also observe disappearance of a solid or appearance of a precipitate. A precipitate is just a one of a product that's comes out of the reaction in solid form or powdered form, crystalline form. That's precipitate. Okay, so example. So if I have, let me just take this off. So this is an example on the board. So if you can measure the rates by time or how long it takes to produce carbon dioxide, then we can actually measure the rate of chemical reaction. So look at some NECO-style question. Okay, so I have this NECO-style question on the board. So it says that which of the following changes will increase the rate of reaction between zinc and dilute hydrochloric acid? So which of them? The first option I have there is A, decrease in temperature. No, we discussed it. B, use dilute acid. Of course, this is not the answer. Use of dilute is not the answer. Increase the concentration of the acid is more likely to be the answer. And if you use large lump of zinc, you will decrease the surface area. Understand? If you are using lumps of zinc, you are going against surface area advantage. Instead, you will use powdered zinc so that you can increase surface area. This is correct. And this one, if you use dilute acid, you are going against concentration. So if you use concentrated acid, it's better. And if you use decreased temperature, you are making the reactions happen in a colder temperature, meaning that the molecules will move slower kinetic energy will decrease. But what you will do against this one is to use high temperature to increase the rate of movement of the particles and enhance collision and also enhance the reaction. So you see the answer is C. Most of this, what we are looking at here, exam style questions, you need to understand the concepts for you to really know what the answer is. If you know the concept very well, if you know how the collision theory is affected by the rates of reaction or the factors affecting the reaction, how they interrelate, anyway, how they ask the questions, you will know. So look at the description of this video. You will see more NECO-style questions. Just go through them or check the comment section. You will see all those questions there. So I hope this video has been informative for you. I'd like to thank you for viewing.